A hurricane is a large swirling storm that can have speeds of up to 119 kilometers per hour that form over warm tropical ocean waters and carries a large amount of water to land, which is called a storm surge, which is heavy rainfall that often causes flooding. So the fast-moving winds form a cyclone which swirls in a circular motion around the eye of the hurricane. And hurricanes are characterized by their high circular wind speeds, which possess kinetic energy. So, to model this hurricane, I use the formula for kinetic energy, which is 1/2 mv squared. And the first thing I did was calculate or estimate the hurricane wind speeds, which I chose 160 kilometers per hour, which makes the storm a Category 2 hurricane. And I estimated the gale force winds will be moving at about 38 miles per hour, or about 61 kilometers per hour. The air density constant for the hurricane, I assumed it was the same throughout, as it's 1.225 kilograms per meters cubed, and converted to kilograms per kilometer cubed, it's 1.225 times 10 to the 9th. So I calculated the hurricane force wind, which down here I broke the hurricane up into 3 sections: the eye, the hurricane, and the gale. And to calculate this part, I took the radius of the eye and the radius of the gale, added them together, and calculated them as their own volumes. Well, I'm sorry. I took the entire radius of the entire storm and calculated this as its own volume, the whole storm as the volume, and I subtracted the hurricane. Well, I subtracted these two parts to get the hurricane force wind. And so far, I calculated it to be 2,151,339.087 kilometers cubed. And I did a similar method to find the gale force wind. Took the whole thing and then subtracted that part away from it, and I calculated it to be the gale force wind was the 2,151,000, and the hurricane force is the 2,012,058 kilometers cubed. And from there, I calculated the total energy in the entire hurricane, or the hurricane force, and it came out to be 3.5 times 10 to the 19 joules. So I took this value and then I just plugged it into the 1/2 mv squared formula for kinetic energy, and I did the same for the gale. I plugged it into the 1/2 mv squared, and I got 4.9 times 10 to the 18 joules. So overall, the entire energy in the hurricane comes out to be roughly 10 to the 19